Alright, if you haven't already, get out your pencil and paper and let's take these notes old-fashioned style. So we're just going to go over two examples on how to solve 3x3 systems of equations. Because each example is pretty lengthy, we'll cover some more in class. After these two examples, there will be one problem for you to try. When we look at this example, I notice that second equation, x is already isolated and it's equal to negative 3y. There's not a z in the second equation. So I can actually use a little bit of substitution here. What I'm going to do is on the first and the third equation, I'm going to replace x with negative 3y. Notice that I put the negative 3y in parentheses. On the top equation, it doesn't make much of a difference because there's no coefficient. But on the bottom equation, I did have that negative that was in front of the x. So now I have negative 3y. I'm going to go ahead and distribute that, which would make a positive 3y. So I can just erase the negatives and the parentheses here. All right. Let's go ahead and combine our like terms. So on this top equation, we have negative 3y, negative 2y, that makes negative 5y, plus 2z equals 7. And on the bottom, we have 3y and 3y and 1y, which makes 4y, minus 4z equals negative 8. Okay, so now I just have two equations with two variables. And y'all already know how to solve that. The way that these two are set up with the y's in line, the z's in line, the equal signs, and then the constants in line, that signals to me that I should probably do elimination. So that's what I'm going to do. So remember with elimination, I want the same number but opposite signs for one of my variables. So right now I have a negative 5y and a 4y, a 2z and a negative 4z. So what would be easiest here is to get rid of the z's, because 4 is a multiple of 2. That means all I need to do is multiply this top equation by 2. So 2 times 2 is 4, and I'll have a positive 4z on top and a negative 4z on bottom. Remember that when you multiply the equation by 2, you multiply everything by 2. So we get negative 10y, positive 4z, and positive 14. And line that second equation back up. And then our next step is to add them together. Negative 10y plus 4y is negative 6y. 4z minus 4z cancels. 14 minus 8, because I'm adding a negative 8, so it's 14 minus 8 would be 6. Now I have one equation and one variable, and all I have to do is divide to finish solving for y, via y equals negative 1. There is the first of my 3 answers. But that's the hardest part. The easy part is finding the rest of them. So we're just going to work our way back through the problem to find the other variables. So looking at all of this work, okay, I have a couple of options here. I need to find the x and the z. So when I look at these green equations, they have only a y and a z. And I already know the value of y, so I could replace my y with negative 1 and solve for z. In my original equations, 2 of them have 3 variables, x, y, and z, and I only know the y value, so I would still have an x and a z, and there I couldn't solve that, not easily. But this middle equation has an x and a y, so I can replace the y and solve for x. So I'm going to do both of those things. I'm going to start here by solving for z. So I can use the top or the bottom equation. I'm going to go with the bottom equation. So let me bring it down here. And I'm going to replace the y with negative 1 and solve. Remember, we're going to distribute first. Then we're going to start getting the z by itself, so I'll add 4 to the other side. We get negative 4z equals negative 4. I can divide and z equals positive 1. There's the second of my 3 answers. So I actually have 2 options here. What I could do is go back to one of my original 2 equations and replace the y and the z and solve for x. But what's going to be easier for us is taking that second equation and replacing just the y. So we got x equals negative 3, replacing the y with negative 1 because y is equal to negative 1. Multiply and we get positive 3. There's the third answer. So I'm going to write my answer in coordinate form, which goes x, y, z. So our answer would be 3, negative 1, 1. There we go. Let's talk about checking our answer. What I can do to check my answer is I can replace the variables in my original equations. So x was 3 minus 2, y was negative 1, and z was positive 1. Let's see if that actually equals 7 like it's supposed to. I would need to multiply these. So negative 2 times negative 1 is positive 2. 2 times 1 is positive 2. 3 plus 2 is 5. Plus 2 again equals 7. Absolutely. It works for that one. I can do a quick mental math for the second equation. Negative 3 times negative 1 is positive 3, which is our x value, so that one works. And then I'm just going to try out this last one. Negative x is 3. So I'm not replacing x with negative 3. It's just there's a negative in front of the x already. Plus y is negative 1 minus 4 times z is positive 1. Let's see if this equals negative 8. I need to multiply that. So negative 3. I don't need to put plus negative 1. I can just put minus 1. Negative 4 times 1 is negative 4. If we combine these together, that's negative 4 minus 4 equals negative 8. It certainly does. So I know that our answer is correct. Now on to a more challenging problem. In this example, all 3 of our equations have all 3 variables. So I'm not going to use substitution here. I'm going to use elimination multiple times. What I'm going to do first is I'm going to pick 2 equations, any 2 equations I want, and I'm going to get rid of one variable, whichever variable I want. When I look at my coefficients, I have a 1, 4, and 1, 5, negative 5, and 5, 5, 4, and negative 1. These y's are looking the easiest to work with because they have the same number and some of them have opposite signs. So I'm going to choose the first 2 because it already has a positive 5y and a negative 5y. I know these are immediately going to cancel when I add those 2 equations together. So I rewrote them. Let me add them. 1x and 4x is 5x. Negative 5y and positive 5y cancels. 5 and 4z makes 9z. And negative 2 plus 19 would be 17. Okay, I can't solve that yet because it still has an x and a z. So what I need to do is create another equation with an x and a z so that I can use elimination on those as well. So I've used the first 2 equations already, so now I have to use this third one. Okay, I can use the third one in conjunction with the first one or the second one. It's completely up to me. But when I look at my y, I have to get rid of the same variable, so it still has to be the y that I'm getting rid of. I see a positive 5y, so I definitely want to use it with the second equation because it has a negative 5y. I've rewritten them. Let's add them together. 4x and 1x is 5x. Negative 5y and positive 5y cancels. 4z minus 1z would be 3z. 19 minus 20 is negative 1. Now look, I have 2 equations that have x and z's. So now I can use elimination on these 2. I'm just going to bring this one over, 5x, and put it in line, plus 3z equals negative 1. Okay, now I'm going to do the same thing. Look at my 2 equations. I got a 5x and a 5x, a 9z and a 3z, it would definitely be easiest to get rid of the x's because they already have the same number. But right now they're both positives. If I add those together, I'm going to get 10. I don't want that. I want one of these to be a negative. So let me go ahead and multiply this bottom equation by -1. Okay, I made sure it multiplied everything in the equation by -1, so it changed the sign of everything. Now I can add these two equations together. 5x and -5x cancels. 9z minus 3z is 6z. 17 plus 1 is 18. I have made it down to one equation with only one variable, so we can finish solving by dividing. I got z equals 3. Now that we have z is equal to 3, I'm going to come back to these two equations, the ones that only have an x and a z in them. I'm going to replace my z with 3 in one of these two equations and solve for x. I'm going to go with this yellow equation. It seems simpler. So you can see that I've replaced the z with 3. And now I can solve. I'm going to multiply. That gives me 9. I'm going to minus the 9 to the other side. 5x equals -10. And our final step, as always, is to divide. X equals -2. Okay, now I know my x and my z value. So I'm going to come back to one of my original 3 equations, the one that have all 3 variables. I'm going to replace x and z and solve for y. I'm going to go with the top equation because I'd rather deal with a -2 than 19 or 20. Alright, I've replaced the x with -2, the z with 3, and now I can start solving this. I'll need to multiply that. X didn't have a coefficient, so I didn't have to put him in parentheses. Gives me 15. I have like terms. The -2 and the 15, I can combine those together. That would be 13 plus 5y equals -2. Now I can move the 13 to the opposite side, so I'll have to subtract it, which gives me -15. And then my last step is to divide. I get y equals -3. Let me write my final answer. X goes first, -2, then y, -3, and then z, +3. And that is the solution to this system of equations. Alright, now it's your turn. I know that wasn't a lot of examples, but go ahead and try this and see how far you can get. We'll talk about it tomorrow during class.